Okay, welcome along Year 11 to homework #5, which is looking at box plots and histograms, and then part B is the area of circles. The date set is the 18th of November, the date due is the 25th of November. So, as what we've been doing recently, the homework is made up of two sections. Section A is box plots and histograms, which is the work you've been doing this week with me in class. And then section B, which will be the next video, is a topic from last year or previous years, which is looking at the area of circles and sectors, which is more revision to make sure we are up to date and we're fresh with that topic. I chose this really from our mock exams. It was answered really poorly, so we're going to go through this. And of course, mark your papers using these videos. It's great that you're here. If you could like the video, makes a massive, well, it'd be massively appreciative, because a bit of time goes into making these, because I want you guys to do really well. But if you could like it, I'd be really appreciative. And that is it really. Okay, so this is going to be the first video looking at Section A, box plots and histograms. So get a green pen, enjoy the ride, and let's mark our work together. So, question 1, we've got this, which is looking at, I've got my mark scheme with me, good. Looking at drawing a box plot, I believe. So here's some information about the lengths in centimetres of leaves. You've got all of this here, and it says draw a box plot to show the information. Now, very, very quickly, just to recap, a box plot, okay, is where you've got something looking like this. We've seen this in class now a lot, but it's going to take this structure over here. Okay, where you've got 5 really key features here. Okay, where the end value on the end, you call this the minimum value. That's the lower quartile, that's the median, that's the upper quartile, and this is the maximum value. So for us, the shortest length is 2.4. So the minimum value is 2.4, and every one square here is worth 0.2, because that'll be 2.2, 2.4, 2.6. So 2.4, we're going to go and draw, and you can draw it anywhere on the grid. I'm going to go and draw it, let's go up here. Okay, 2.4, that one's done. Good. The longest length is 9, that's the maximum value. That's going to go, and you've got to kind of keep it symmetrical. 9's going to go up there. So I've just chosen to go 2 squares up either way from this line here. The upper quartile is 7, and the upper quartile is this part of your diagram. And just make sure that this bit is longer than the end bits, okay, the whiskers. So the upper quartile is 7. I'm going to make it really thick. Okay, that's pretty thick, but it's fine. It's longer than the end bits. The median, which is 6, is this part of your diagram. So 6 is going to go there, and then the, oh, that's a bit messy, sorry. Going to go up there, making sure you guys are using a ruler and pencil. And the interquartile range is 3. Well, this whole thing, the upper quartile minus the lower quartile, is the interquartile range. So if I've got the upper quartile being 7, if I take away 3, that will give me the lower quartile. Okay, that's going to be 4. So this part over here gives me 4. Join it all together nice and neatly. Okay, there we go. There we go. There we go. And there we go. And that's it. And how easy, guys, is that 3 marks there? Again, in the mocks, nearly all of us, I think, got this kind of question incorrect. It's not because you're bad at maths. Your maths is so good, guys. It's because you're not exposed enough to these questions yet. Yeah, once you've seen this now and you practice it, you can do this. It's all past paper exam practice. Yeah, there's no complicated maths there at all. It's easy 3 marks. And that is it. Okay, so that's part 1 done. And then on to question number 2. Which says this, 180 runners, so that's the total number of people, started a marathon. Some of the runners did not complete it. So some of them did not complete the marathon. The histogram on the next page shows the times of the runners who did complete the marathon. So I'm guessing on this page here, these guys here, they did complete the marathon. How many runners did not complete the marathon? Now the key thing is here is to know that the area of the bars on histogram is frequency, how many people there are. So basically all you want to go and do here is work out the areas of each of these rectangles, add them all up and take them away from the total 180. These are people that did the marathon, and these are people that started the race. If I add up all of these areas here, that will give you the people that did not finish. So let's label up our rectangles. Number 1 first of all, 2, 3, 4, and then 5. Okay, because remember this diagram here, it says is the people who did complete the marathon. So let's go and get these people. If I look at rectangle number 1 to begin with, it's got a base of 20 and it's got a height of 0.8. Every square is worth 2 squares is worth 0.1. So that's 0.8. So 1 is going to be, the width of it is 20, times it by 0.8. You can use a calculator here. That's going to give you 60. Done. Rectangle number 2, the base of it is from 160 to 180. That's 20. The height of it is 1.8. That's 1.8. So you've got 20 multiplied by 1.8. That gives you 36. I'm going to double check that, but that should be good. Number 3, okay, the rectangle's got a base of 180 to 220 is 40. The height of it is, that's 1.2. So 40 multiplied by 1.2, and that gives you 48. Rectangle number 4, that's got a base of 220 to 260. That's 40 times the height of it, which is going across 0.7. So you've got 40 times 0.7. That gives you 28. And then number 5, the base of it is 60. And the height of it is 0.4. So 60 times 0.4 gives you 24. Now if I add these all together, I get 152. If I add these numbers here, 16 and 36, 48, 28, 24, I get 152. These are the people, okay, these are the people who completed the marathon. Therefore, the people that did not finish is the total 180. Okay, so 180, take away the 152, and that gives you 28. So 28 people did not complete the marathon, and that's the answer. And how many marks is that? That's a 3 marker, guys, okay? And how easy is that? Right, again, if you've not seen this question before, you're not going to get the marks on it. You've just got to know that area is frequency. The maths here is so easy, isn't it, guys? You're just finding the area of rectangles. And now you've practiced this, and you're going to practice a few more now. If you see this again, you're going to know what to do. So it's just all about exam practice. If you got 28, amazing, good work. And then part B is this. It says the table below shows information about the runners who did not complete the marathon. So you've got some information here, and then the question says, draw a box plot to show the information. Right, we've just done this on question 1. So let's begin with the least distance, which is 5. And every square here, 2 squares is worth 1. So that's 5, 6, 7. So the least distance is 5. Let's go and put that over there. Done. That one's finished. The greatest distance is 23. Okay, so 23 is going to go 21, 22, 23 is going to go up here. Okay, 23, 24. That's good. I've jolted it. There we go. That's 23 there. The lower quartile is 11. 11's going to go there. Let's make it a little bit longer. That's good. That one's done. The median is 18. That's going to be 18 up there. Okay, 18 goes there. Make it a little bit neater. 18 goes there. 19, 20, 1, 2, 3, good. And then the interquartile range is 9 again. Well, if the lower quartile is 11, if I add on 9 to this, okay, 11 plus 9 will give me 20. That's going to be the upper quartile up there. Let's make sure I've got my lines. 20 is going to go up there. Good. I just join it all together. Okay, there we go. Go across, and we go across again. And there we go. Good, finito. And again, guys, right, 3 marks in the bag. So this question is 3 marks. The previous one was 3 marks. That is 6 marks of questions in the bag. Yeah, and how easy is that really, guys? Okay. Question number 3. Let's have a look. The question says this. A basketball team plays 19 home games. Home games has been done for you. And 19 away games, which is going to be down here. The box plot shows the home games, as I've we've just seen really. Here are the points for the team scored in the 19 away games. There we go. On the grid, draw a box plot for the away games. Music to our ears. We know how to do this. Let's begin by getting the median for the away games. And to do that, we've got to begin by crossing off our numbers. So let's go from the start and then the end. The start, the end. And we keep working through. First, just double check, are your numbers in order from smallest to biggest? Yes, they are. So we're good. Keep crossing off, keep crossing off. Cross off, cross off. Keep crossing off. Okay, until we get to, there we go, until we get to this value, which is the median. This is the median. Okay, let's go and plot it onto our grid. So 99 is the median. Every square is worth 1. Make it go, there we go, up there, perfect. And just make sure now that you are consistent that this kind of thing is one big square along, and so is that one. Good. That is 99 is our median. Now to get the lower quartile, I've got to go and look at the lower portion of my data, so everything to the left of the median, and I cross off from these values. So I go from the start here, end here, start here, end here, start here, end here, start here, end here. I can see here that 96 is the lower quartile. So I'm going to go and plot this one now on my grid. Okay, so 96 is going to go there. Oh, let's keep it the same color. 96 is going to go there. Good. And then similarly, okay, to get the upper quartile, look at everything to the right over here. And I cross off from the start and the end. Start and the end. Start, end, start, end. The upper quartile is 109. Let's go back to that one now. So 109 is the upper quartile over there. Good. Let's just join these together. Good. And then good. And then all I want now is the maximum and the minimum values. Well, the maximum value is really easy, is 126. Let's go and plot that. 126, making it a little bit smaller. It's going to be 3 squares. There we go. The minimum value is 85, isn't it? So that's the smallest value. 85 is going to go over there. Good. Across. And there we go. And you have answered the question. Okay? And how many marks is this one? This is worth... Oh, let's go to this. This is worth 4 marks, guys. Right? That is a 4-mark question. Yeah? For this. You can do this. But again, if you're not exposed to this kind of question, you're going to get it wrong in the exam. That's why you've got to practice it, because the maths here is not complicated. It's just being exposed to the question. Good. We've then got part C, which is saying, was the number of points scored more consistent in the home games or the away games? Okay. Right. Consistent. That word we've been speaking about. Have I missed that question? Sorry, I have. Guys, sorry, missed that question. Part B, on average. Okay, when you hear that word average, you should be thinking, right, perfect, I know what to do here. Average is either the mean, the median, or the mode. Now the question says, use one statistical measure to support your decision. Now from box plots, can you get the mean? No. Can you get the mode? No. You can get the median. So we've got to be using the median. We're using the median. So go and get the median for the home games. For the home games, the median is this value here, 106. Okay, so the median here is 106. And for the away games, the median, okay, is 96. 96. Okay, sorry, 99. The median, this value here, is 99. So you just go and say, well, on average, who got the highest score? So if we look at the home games, okay, what was the score there? It was 106. And for the away games, the value was 99. Now we've got to go and put this into sort of some words here. So on average, which team, on average, sorry guys, my thing's glitching out. Okay. on average, which team scored more? Let's have a look. Okay, so home, because the median, and you've got to say the median is bigger. Okay, 106 is bigger than 99. And there you go. So the keywords here is home, the median. So let's go put this in red. Right, that's the answer, home. Good. You've got to state the median. Okay, let's go make this red. And then the end bit is there. Okay, I can't. Right, the last key bit, I can't highlight it, is this part. So you're looking at the average, you've got to compare the median. You say which team got more points. Okay, so who got more points? That's the home team. And you give the numbers there. And that's it. Okay? Good. Part C. Let's zoom out a little bit. That's fine, isn't it? Was the number of points scored more consistent? Now, when you hear that word consistency or varying or ranging, you think, or spread, you think of, right, how do you compare consistency or variability or spread? This is all to do with either the range or the interquartile range. We've been doing this to death in class, guys. We're really good at this. So you're spotting the keywords here. Average is the mean, the median, or the mode. Consistency or spread or variability is the range or the interquartile range. Now, personally, I would always compare the interquartile range. So going back to our diagrams, if we look at this was the medians. If I go over here, that's going to now compare the interquartile ranges. For home games, the upper quartile is 117, the lower quartile is 95. So 119, take away, so 117, take away 95, gives you 5 and 17 is 22. Okay. And for this one, I've got 109 take away 96. Sorry, 109 take away 96. 109 take away 96, which gives you 4 and 9, gives you 13. Okay, let's double check those numbers. That's good. Yeah, good. So these are our key numbers. So home was, I've forgotten already, 22, and away was 13. Let's go and type it into words now. Okay, so who was more consistent? If you're more consistent, you've got less spread. There's less variability. So the away team, 13, is smaller. So the away team is more consistent, because the range is lower. And you go and say because 13 is less than 22. Yeah, and you've answered the question there perfectly. There we go. Good, so we've got the keywords here. So you state the answer. I'm just going to highlight it, it's easier. Right, away is the answer, more consistent because the range, because remember, to measure consistency, it's either, sorry, right, not the range, apologies, the interquartile range. The interquartile range is lower. 13 is less than 22. You could have also compared the ranges, but I would always go for the interquartile range personally. Okay, let's zoom out so you can see both parts there. Let's just zoom out there. Escape. I can't seem to be zooming out. That's not very useful. Let's go to this. Why can't I zoom out? Okay, that's not very good. There we go. That's all of question on 3, B and C there. Good. Question 4 is this. You've got, in the UK 2000, 25% of the population were under 24 years old. Now, just to kind of recall, right, a box plot, because I can tell the kind of style of the question that they're going to be asking here. A box plot, we've got the key parts here. Okay, just a really quick sketch. Okay, there we go. There we go. Just so we know, in a box plot, from the minimum value to the lower quartile is 25% of your data. From the median, from the lower quartile, sorry, to the median is another 25% of your data. From the median to the upper quartile is the next 25% of your data. And from the upper quartile to the max value is another 25% of your data. So a box plot is broken up into 4 parts. The min value to the lower quartile is where 25% of your data occurs. The lower quartile to the median, another 25%. Median to the upper quartile, 25%. Upper quartile, max value, another 25%. So 25% of the population was under 24 years old. That means your lower quartile and left, everything under is under 24. So you can go and put this on your grid and say, well, the lower quartile must be 24, which is going to go, that's going to make it a little bit thicker. It's going to go here, okay? And that's actually going to be going, sorry guys, 24 is going to be 20, 20, 22, 24, get given 2. So 24 is going to go there. And then 25% of the population were under 24. So that's going to be from here all the way to 0 years old. Because population is measured in from 0 years old. So that makes sense. Let's check the mark scheme. That should be fine. Lower quartile is 24. End is 0. Good. That one's done. Perfect. It then says 50% of the population were under 37 years old. Now, if you're under 37 years old, 50%, we're going from the median and left, because this to the left is going to be everything under 37. And 25% at 25% is 50%. So if that's going to be 37, everyone to the left of that is going to be younger. So from 37 to 0, and 50% is going to be that 25 and that 25. So let's go and find 37 on our diagram. That's going to go 32, 34, 36. 37 is halfway in between the squares. It's going to go there. So 37, I should really go and write on the values here. So the minimum value is 0. The lower quartile is, that's 24 there. The median is 37. It says the interquartile range was 32. Well, that's going to be your 24 plus the 32. So this number here is 24. Add 32 will give you the upper quartile. So we're going to go and do 24, add 32. Gives you 56. Okay, check the mark scheme is looking good. That's correct. So 56 is going to go there, I believe. 60, 58, 56, good. There we go. So the upper quartile is equal to 56. And then the maximum value was this person, 107, nice and easy. So the oldest person, 107, crikey. 102, 104, 106, 107 is going to go there. Keeping it symmetrical. It's half in between the squares again. There we go. And then across. And there we go. Hopefully that made sense. That's really messy, isn't it? That's a shocker. Let's try that again. Hopefully, guys, that made sense. That's a good question. That would catch quite a few people out. But again, now you've seen this kind of question and you've been exposed to it. And if you understand it, if you see it again, you have a chance of answering the question, which is amazing. Okay, part B says, it is predicted that in 2050, the age distribution in the UK will have a lower quartile of 26, a median of 44, and an upper quartile of 66. And here we go. The same kind of question again, guys, we've been looking at in class and the video. Make 2 comments. Make 2 comments about the predicted change. Right, this comments part, when you're looking at box plots, what can you compare? You can compare either the median, okay, or the range, but let's go for the interquartile range. And remember, the median, right, is a measure of average, and the interquartile range is a measure of spread or variability or consistency. These are the things you compare with box plots. Yeah? So if we look at the median, if we look at if we look at this first part, okay, which is in, what year is this? This is for the year 2000. So this is 2000. The median is 37. This value here is 37. So let's go back to this. In the year 2000, the median is 37. If we look at the median for 2050, the median is 44. So the median for 2050 is 44. If we look at the interquartile range, the spread for the year 2000, first of all, okay, well, the interquartile range is going to be, it tells you, doesn't it, 32. So 56 take away 24 gives you 32. Okay, so 32. And then for the year 2050, we can work it out. It's going to be the upper quartile, 66, take away the lower quartile, 26. Nice and easy. Gives you 40, doesn't it? So there we go. So this is what you're comparing, but you've got to go and put it into words. So 2 comments about the age distribution. You're going to say, and the context here is people living in age, isn't it? So who's got the higher median? 2050. So you can go and say on average, because the median measures average. This is the first keyword, on average. Okay? On average, in context, you're going to go and say this. It's got it wrong. On average, I can't type. Sorry, guys. On average, people in 2050 will live longer because the median is bigger. And you go and state 44 is greater than 37. And that is a textbook answer, guys. That is a fantastic answer. And actually, right, it isn't that complicated, right? You've just got to put in the keywords here. So I'm not quite sure why that went there. That's not very useful. Let's go to this. Let's make it a bit bigger. There we go. Good. So the keywords here, on average, and you put it into context. The people in 2050 will live longer because the median is bigger. And hopefully I've got the right numbers. I'm going to check the mark scheme. I hope I've not misread anything. Let's have a look. This is question 4, isn't it? Yeah, that looks good. Guys, if I made a mistake reading anything, just let me know in the comments. That should be fine. And then comment 2, we're going to be looking at comparing the spread or the variability or the variation. So let's go and do that. You can go and say the ages will vary more because vary more spread, they mean the same thing in 2050 because the interquartile range is larger. 40 is greater than 32. And that is a great answer, guys. Yeah, the interquartile range will vary, more spread. So the ages will vary more spread in 2050 because the interquartile range is bigger. That is a textbook answer, guys. Yeah. Good. Question 5. Let's have a look. It says this. The histogram shows information about the times some children took to complete a puzzle. Estimate the number of students who took less than 85 seconds to complete the puzzle. So first of all, let's go and find 85 seconds on our diagram. Okay, 85 seconds is this point. It's going to be kind of halfway in between 80 and 90. It's going to be there, isn't it? Okay, and right, you know that area of a histogram, area represents frequency, how many people. You want basically everything to the left of 85. So you want everyone in this box here, in this box, okay, and in this box, everything that's lower than 85, so everything over here, okay? So let's go and do that. Let's get rid of all of this now. Okay, so you want everything there. Let's go and get rid of this as well. Let's go make it a little bit neater. So 85 is going to be there. So basically, right, you want the area of 3 rectangles here, of the first one, the second rectangle, and the third one. You want the area of these 3 here. If I look at rectangle 1, because everyone here is less than 85, rectangle 1 has got a width of 80 to 85, which is a width of 5, you times that by the height of it, which you can see is just simply 1. 5 by 1 gives you 5. Rectangle 2, the width of it, 70 to 80, is 10. The height of it is 0.6. So you've got rectangle 2, you've got 10 times 0.6 gives you 6. Rectangle 3, the width of it is 40 to 70, that's 30 times 0.3. Okay, and 30 times 0.3 gives you 9. If I add these numbers together, 5 add 6 add 9, if I add them, I get 20. Okay, and that's the answer. Again, if you've never seen that kind of question before, you're going to get it wrong in the exam. But if you know, right, that just area of a histogram is frequency, how many people there are, you're going below 85, so 85 and below is everything within these rectangles. And that is it. It's just area of rectangles. That's it. I think that's it. And we've got question 6. Okay, is how many more questions have we got here? Got a bit of a long video, isn't it? Okay, 2 more to go. Getting a little bit late, guys. If I'm getting a bit mumbly, apologies. I'll do my best to try and stay awake, but I want to get this out for you guys. So let's keep going. Question 6. You've got the table shows information about the height of 40 plants. Draw a histogram. So just a bog standard histogram question. Now, to draw a histogram, you need frequency density. So you need to do frequency density FD means frequency density. This is equal to the frequency divided by the class width. Okay, we went through this in class. There we go. This is the formula that you guys need. Okay. Now the class width is just the difference between the intervals. So between 0 and 5 is a difference of 5. Between 5 and 15 is 10. Between 15 and 25 is 10. Between 25 and 50 is 25. And then this section is to get the frequency density, because you need that on your diagram. Okay. So let's have a look. If we go and do, on this one, you do the frequency, which is 6, and you divide it by the class width. 6 divided by 5 gives you 1.2. 15 divided by 10 gives you 1.5. 9 divided by 10 gives you 0.9. And 10 divided by 25 gives you 0.4. So looking at the first one, we're plotting between 0 and 5. Okay, so we're going between 0 and 5 and a height of 1.2. So we're looking at plotting this with this, because the height is down here, the frequency density is this part here. So between 0 and 5, going up to 1. We're going to put up an axis here, right? So if that's the smallest value is 0.4, the biggest value is 1.2. You can choose the scale here. Let's go for that being 0.1, 0.2, 0.3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go for 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4. Let's go for every block up here being worth 0.2. So you want to make it as big as you can. Let's make that 0.2. Let's make that 0.4. Let's make it a little bit neater for you guys. Sorry, I'm being really rushed now, guys. Sorry. Let's make this one here 0.2, and then 0.4, and then that's going to be 0.6, 0.8. Let's make that 1, 1.2, 1.4, 1.6, 1.8, and let's make that 2. Guys, I'm sorry, it's really messy. I'm pretty rushing a bit, but I want to do this quite quickly for you guys. Now, that's good, a good scale, because I'm going to include the maximum value, which is 1.5, isn't it? And it kind of uses up a lot of the graph, which is good. Now, between 0 and 5, and then 1.2, 5 is there, 1.2 is up there. So we go across, there we go, done. I've then got between 5 and 15 and 1.5. So between 5 and 15 is going to be there, and 1.5 is going to be in between 1.4 and 1.6. So there, we go across and then down again. That one's done. I've then got between 15 and 25, which is 0.9. So 15 and 25 is 0.9, which is going to go there and across. There we go. Then between 25 and 50, which is 0.4, 25 is there, 50 is up here, and 0.4 is over there. And that's it. Okay, you've drawn the histogram, guys. Now, hopefully I've made no mistakes there, but that should be it. Perfecto. Last but not least, question 7, because it's getting quite late. We're doing good. This looks like a lovely question. Let's have a look. A company makes tubes of toothpaste. The masses of 80. Okay, so you've got 80 tubes are checked. So everything in this histogram is going to be worth 80 people. The histogram is drawn to represent the data. The company makes 28,000 tubes each day. Estimate how many tubes each day have a mass less than 122. Right, this is actually it's a good question. If I've got it correctly. So, right. The masses of 80 tubes are checked. So everything here is worth 80. Ignore that line for the time being. Estimate how many tubes have a mass less than 122 grams. Let's go and find 122 first of all on this. Okay, so 122 is going to go, each of these squares is worth 1, 122. That's not quite right, is it? Let's go across here. Okay, what I'm thinking, guys, is right. I'm just thinking this on the spot. If I can find everything less than 122 grams, well, if that's 122 there, everything less is the half of, well, the part of this rectangle here and this one. And whatever value that is, I can upscale it to 28,000 by finding, we'll see. But basically, right, guys, here you've got two rectangles, rectangle 1 again and rectangle 2. Let's find the area of rectangle 1 to begin with. Okay, so rectangle 1, it's going to have a width from 120 to 122. It's got a width, rectangle 1, it's got a width of 2, and it's got a height of 4. Okay, because remember, to get how many things you've got, remember, area gives you frequency, how many things. So 2 times 8 gives you 16. So there's 16 what are they? Toothpaste tubes in this one. In rectangle 2, the width of it is equal to 10. And the height of it is worth, what is that? 0.6, I believe. Yeah, I think. Yeah, so 10 times 0.6, which gives you 6. So in total, right, you've got, in this kind of sample of 80 tubes, you've got 16 plus 6, which is 22. Which is 22. Okay, so you've got 22 tubes here that are less than 122. Now, as a fraction, you've got less than 122 grams. You've got 22 of them are less than 122 out of 80. Okay, so this is the fraction of tubes that are less than 122 grams. Okay, now if you test out 28,000 tubes in a day, if you go and say, well, what's this fraction of this amount, that's going to be the estimate of the tubes that have a mass less than 122. If that makes sense. So we can go and say, well, in the sample, there's 22 out of 80 that have a mass less than 122. Now, of means times of 28,000. That should give me the answer I'm looking for. Okay, I'm hoping it is, because I've not looked at the mark scheme. If I go and do this, let's have a look. So I've got 22 over 80. 22 over 80. I'm going to times that by 28,000, and that gives me 7,700. Okay, which is not looking correct on the mark scheme. Right, let's have a look. That gives me 7,700. Okay. Right, what's happened there then? This is a bit of a bummer. Last question. Let's double check what I've done wrong, if I've done anything wrong, if I've misread it. I've got definitely 2 there. Oh my goodness. Oh, sorry guys. Right. This number is not 8. It's 4. That's really silly. Sorry, guys. Right. That's just a bit of tiredness. This number is 4. Okay, there we go. Let's change this. I've done it in red. Sorry, guys. That's not useful, is it? Okay, I'm not going to redo the video because it's going to take too long. But 2 times 4 is 8. And then if I add these together, I don't get 22. I'm going to be getting 14. So I've got 14 over 80. Okay, and not 22 over 80. It's going to be 14 over 80. Okay, let's have a look. So we've got 14 over, let's go write it properly for you guys. We've got 14 over 80. Hopefully if I times this by 28,000, what do I get? 4,900. And hopefully that's correct. Hopefully that's correct, guys. Let's have a look. Let's check the mark scheme in a second. I've got 4,900. And the mark scheme says 4,900. Perfect. Okay, go for that. That's really useful. But that's fine. Look, even guys, with my incorrect answer, I would have only lost 1 mark because I just made a mistake early on, but I followed through with the correct working. Now, this is the most complex question. Definitely. That's more, you've got to think more deeply about it. But again, right now, you've seen this kind of question, guys. If you saw something similar again in the future, you could definitely give it a go, or give it a good go. But that is part A of the homework done. If it was useful, please do drop a like. I would really appreciate it. But guys, keep smashing it. Keep doing the homeworks. Keep doing the past paper questions. And yeah, if you could leave me a comment if you're enjoying it or if you find it useful, it gives me a bit of inspiration. So that'd be fantastic. Drop a like. Keep doing really well. And yeah, well done, guys. You're doing amazingly. Just keep doing the questions. And have a good evening or morning or wherever.